Today we're going to do lesson 15 problem set that is all about relating arrays to tape diagrams to model the commutative property of multiplication. So we are kind of combining two things that we have already been working on. We've already been looking at arrays, we've been looking at tape diagrams, and we've discussed the commutative property. So we're going to see how those two things fit together. Problem 1 says label the tape diagrams and complete the equations. Then draw an array to represent the problems. So, letter A, we have a tape diagram that has 4 in each section, and there are 2 sections. So we can see that each section is worth 4, so the whole entire thing, or my total, would be 8. And you can see that we're kind of taking a step back from our labeling to where we don't have 2 labels for each part like we have been. So my multiplication equation for this array would be 2 times 4. And we know that 2 times 4 is 8 because we said our total at the bottom was 8. So if we flip-flop that, we now, instead of having 2 sections with 4 in each section, have 4 sections with 2 in each section. And remember, I'm dealing with the same number, so that means my total is going to be the same. Because when I flip-flop my factors, my product is the same. So 4 times 2 is 8. Now we have an array here to represent the problem. Something that I would like to maybe do is draw 2 arrays to represent our problem, because we could draw one that matches our top array and one that matches our bottom array instead of having to visualize it flip-flopped. So with this one we have 2 rows of 4. So for our bottom array we could do 4 rows of 2. Just flip-flopping our array. Alright, let's look at letter B. Letter B is missing a little bit more information, and then you'll notice letter C is missing almost all of our information. So it's kind of nice that we can start out and then have to figure out a little bit more as we go. It's kind of like a puzzle. So for our first array we have 3 sections, and there are 4 in each section. Now the first one's been filled out for us, so we can fill out the rest. Alright, and then I can even go down to my next one and I can fill out the rest of those. Okay, and then I can make my pen tool small again. So, I have 4 in each section, which leaves me with how many total? Well, I can skip count by 4s. 4, 8, 12. So that's 12 total. Now my multiplication sentence is 3, because I have 3 sections, times 4 equals 12. For my next tape diagram, remember we're flip-flopping. So I now have 4 sections with 3 in each section. So what am I going to put here? Right, I'm going to put 3 because there's 3 in each section. And then down here is for my total. And if my total on the top was 12, then my total on the bottom is 12. Okay, so now my multiplication sentence is 4 times blank. I have 4 sections with 3 in each section equals 12. Alright, last one, letter C. So if you would like, you can definitely try to work this one out on your own, and then you can check back with me to see how you did, or you can keep going with me right now. So for letter C, I can see that I have 1, 2, 3, 4 stars, and then I can draw those 4 stars in my other boxes. Alright, and then I can fill out my blanks. My blank up here is for what? The number in each section, and that number is 4. My number down here is my total. So let's count by 4s. counting by fours is something that is, not something we practiced a whole lot. So we might have to count dots. 4, 8, 12, 16, 20, 24, 28. So my total is 28. Now you may have noticed something with our multiplication sentence. If you look, you can see that they actually gave us our total and said it was 28. So hopefully our number that we counted matched our total over here, and it does. That's kind of why I kept that a secret when we started. Okay, so let's write our multiplication sentence. I have how many sections? 1, 2, 3, 4, 5, 6, 7. 7 times 4 equals 28. Now let's flip-flop it. So if I'm flip-flopping, how many am I going to put in each section this time? Well, I have 4 sections, so there must be 7 in each section. All right. And then we can label. So I just said that there were 7 in each section. And what was our total? 28. Okay, because we know that we're flip-flopping, so my total is the same as up here, and it says so in my multiplication sentence. All right, let's write our multiplication sentence and we'll be all done with this problem. How many sections do we have? 4 times how many in each section? 7. 4 times 7 equals 28. And I completely forgot about drawing our arrays. So let's go back and do that. We'll start with this problem. So for my top tape diagram, I can see that I should have 7 rows of 4. All right. And then I, down here, should have 4 rows of 7. All right. And then let's go up to problem B. It's nice because I have my multiplication sentences to look at to help me with my arrays. My first tape diagram and multiplication sentence was 3 times 4 equals 12. So 3 rows with 4 in each row. If I flip-flop that, I have 4 rows with 3 in each row. There we go. So now we have our arrays to match our tape diagrams. On to page 2. Draw and label 2 tape diagrams to model why the statement below is true, or the statement in the box is true. Our statement in the box says 4 times 6 equals 6 times 4. Let's get started. I'm drawing 2 tape diagrams. My first one is showing me 4 times 6. So I need 4 groups of 6. Don't forget your labels. What am I going to label my top? 6. My bottom? Let's count. 6, 12. I know 12 plus 12. 12 plus 12 is 24. All right, let's do our second tape diagram. Instead of having 4 groups of 6, this time I'm going to have 6 groups of 4. And my labels. what am I going to label the top? 4. And the bottom? Well, let's count. 4, 8, 12. 12 plus 12 is 24. Now, with the commutative property, I know that my answers are the same. But if I'm trying to prove, then I wanted to make sure to count so I can double check. 4 times 6 equals 24. 6 times 4 equals 24. So, 4 times 6 equals 6 times 4. Problem 3. Grace picks 4 flowers from her garden. Each flower has 8 petals. Draw and label a tape diagram to show how many petals there are in total. So we have to draw a tape diagram, so we'll start with our rectangle. I know that I have 4 flowers, and each flower has 8 petals. So let's think about our groups. Are there petals on flowers or flowers on petals? There are petals on flowers, so my 4 flowers are my 4 groups. And that means that there are how many in each group? 8. All right. Now let's label. My top label for my 1 flower is 8 because there are 8 petals. Now let's figure out our total. 8, 16, 16 plus 16. If I don't know that one in my head, I can write it down. 6 plus 6 is 12. 1, 2, 3. 32. So, 4 groups of 8 is 32. There are 32 petals total. I can also write a multiplication sentence. 4 groups times 8 in each group equals 32. All right, we're on our last problem. Michael counts 8 chairs in his dining room. Each chair has 4 legs. How many chair legs are there all together? Now this problem doesn't tell me how I have to solve it, so you can choose the method that you would like to use. You can draw a tape diagram, an array, equal groups, a number bond, a skip count. Possibilities are endless. I'm going to use a tape diagram since that's what we're practicing right now. So I have 8 chairs. Each chair has 4 legs. So let's think about our groups. Do chairs have legs, or do legs have chairs? Chairs have legs. So I have 8 chairs, which means I need 8 groups. Four go in each group. Drawing a tape diagram is kind of just like drawing equal groups, isn't it? Let's label. There are 4 in each group. And if I count by 4s, 4, 8, 12, 16, 16 plus 16. This is starting to sound familiar. I'm pretty sure I just did 16 plus 16 up here. 16 plus 16 is 32. There are 32 chair legs in total. If I write a multiplication sentence for this problem, I notice 8 groups times 4 in each group equals 32, that is flip-flopped from my problem I just did. That commutative property is really, really helpful. That's it for our lesson for today. Don't forget to save as M1L15 so you can use these problems to help you on your word work.